Now let us take some problems based on plane passing through the intersection of two given planes. So here the first question is find the equation of the plane passing through the line of intersection of the planes. Here we are given the equation of two planes and the plane which passes through the intersection of these two planes is parallel to x-axis. So viewers, here the equation of plane P1 is r dot vector vector I plus j plus k equal to 1, and the plane P2 is vector r dot 2I cap plus 3j cap minus k cap plus 4 is equal to 0. Now the Cartesian form of this equation is x plus y plus z minus 1 equal to 0, and the Cartesian form of this equation is 2x plus 3y minus z plus 4 is equal to 0. Right? Now this is the first plane, this is the second plane, and the equation of the plane which passes through plane passing through the intersection of P1 and P2 is given by P, and this plane P is P1 plus lambda P2 is equal to 0, where lambda is some parameter which is to be found out with the help of the given condition, and here the condition is the plane is parallel to x-axis, right? So here we will substitute P1. The value of P1 is x plus y plus z minus 1, and then we have lambda P2 is 2x plus 3y minus z plus 4 is equal to 0. Now this can be written as 1 plus 2 lambda x plus 1 plus 3 lambda times y plus 1 minus lambda z and plus minus 1 plus 4 lambda equal to 0, right? Now viewers, here we have this plane P1, here we have plane P2, and the plane passing through the intersection of this plane P1 and P2 is given by P, and this is the line of intersection of these two planes, and the drs of the normal vector which is the normal vector to this plane P are given by 1 plus 2 lambda, 1 plus 3 lambda and 1 minus lambda, right? Because this is the Cartesian equation of this plane P, and the coefficients of x, y and z are the direction ratios of the normal vector to this plane P. Now here the condition is given, this plane P is parallel to x-axis. So if the plane P is parallel to x-axis, then it implies that the normal vector is perpendicular to x-axis, right? And the drs of x-axis are 1, 0 and 0 here, and we can have the condition of perpendicularity of two vectors. Two vectors are said to be perpendicular if a1 a2 plus b1 b2 plus c1 c2 is equal to 0, where a1 b1 c1 are the drs of the first vector and a2 b2 c2 are the drs of the second vector. So here a1 b1 c1 are 1 plus 2 lambda, 1 plus 3 lambda and 1 minus lambda, and a2 b2 c2 are 1 0 and 0. So therefore we have 1 plus 2 lambda times 1 plus 1 plus 3 lambda times 0 and 1 minus lambda times 0 is equal to 0. Now if we solve this, we get 1 plus 2 lambda equal to 0. This implies 2 lambda equal to minus 1 and lambda is equal to minus 1 by 2, right? Now the equation of the plane P is given by this expression. So if we substitute this value of lambda here, we have 1 plus 2 times of minus 1 by 2 x plus we have 1 plus 3 times minus 1 by 2 times y plus 1 1 plus half, here we have z, then here we have minus 1 minus 4 by 2 equal to 0, right? So we have substituted this value of lambda as minus 1 by 2 in this equation. So we have obtained this expression. So here we have 2 and 2 get cancelled, so we have 1 minus 1, that is 0. So we have 0x, then here we have 1 minus 3 by 2 times y, and here we have 3 by 2 z, and here we have 2 2 are 4, so here we have minus 3 equal to 0, right? Now therefore this becomes 0, and here we have minus half y, this is 3 by 2z minus 3 is equal to 0. Now if we multiply the whole equation by minus 2, we get here y, here we have minus 3z, and here we have plus 6 equal to 0. So viewers, this is the required equation of the plane which passes through the line of intersection of these two planes and parallel to x-axis. Now let us take this problem. Find the equation of the plane passing through the line of intersection of this plane, which is P1, and this plane, which is P2, and which is perpendicular to the plane this P3. And here we have converted these vector equations into Cartesian form, and here we have the diagram. This is the plane P1, this is plane P2, and this plane which we have to obtain is passing through the line of intersection of these two planes. So the plane P has the equation P1 plus lambda P2 equal to 0, right? Now this plane is passing through the line of intersection of these two planes, and the equation of this plane P is given by P1 plus lambda P2 equal to 0. Lambda is a parameter, and we have to find the value of lambda. Now P1 is here, if we substitute the values, we get x plus 2y plus 3z minus 4 plus lambda times 2x plus y minus z plus 5 is equal to 0. Now this can be written as 1 plus 2 lambda x plus 2 plus lambda y plus 3 minus 3 minus lambda z, and here we have minus 4 plus 5 lambda equal to 0, right? Now this is the equation of this plane P, right? Now this plane P is perpendicular to this plane P3. So let us draw the plane P3, and the plane P3 may be drawn like this, and these two planes are perpendicular. P is perpendicular to P3, and it means that the normal to this plane P, is say vector n, and the normal to the plane P3 is like this, and say this is n3, and we see that if two planes are perpendicular, then their normals must be perpendicular, right? So vector n is also perpendicular to vector n3, right? So what we have concluded here, this plane P is perpendicular to this plane P3, and when two planes are perpendicular, their normals are also perpendicular, right? Now the direction ratios, dr's of vector n, this normal vector, are 1 plus 2 lambda, 2 plus lambda, and 3 minus lambda. And the dr's of vector n3, this n3 vector are 5, 3 and minus 6, right? Now we know that when two vectors are perpendicular, then the condition is a1 a2 plus b1 b2 plus c1 c2 is equal to 0, right? So what we will do here, we will multiply term by term and then we will add. So we have 5 times 1 plus 2 lambda, then we have 3 times 2 plus lambda, then we have minus 6 times 3 minus lambda equal to 0. Now we solve it. 5 plus 10 lambda, we have 6 plus 3 lambda, we have minus 18 plus 6 lambda equal to 0. 6 plus 3 9 plus 10, we have 19 lambda, and then we have 6 plus 5 11, and 11 minus 18 is minus 7, and this is equal to 0, so lambda is equal to 7 by 19, right? Now we will substitute this value of lambda in this equation to get the equation of plane P. Now the equation of plane P becomes 1 plus 2 sevens are 14 by 19. Here we have x plus 2 plus 7 by 19 y, and then we have 3 minus 7 by 19 z, and then we have minus 4 plus here we have lambda 7 by 19, so it is 35 by 19, right, equal to 0. Now here we have substituted this value of lambda and we have obtained this expression. Now we simplify it, so this is 19 ones are 19 plus 14, that is 33 by 19x plus 19 to the 38 plus 7, that is 45 by 19y, and then we have 19 3s are 57 minus 7, that is 50 over 19 z, and then here we have 19 4s are 76, and 76 plus 35 minus 76 plus 35, this is minus 41 divided by 19, right? Now multiplying throughout by 19, the required equation of the plane is 33x plus 45y plus 50z minus 41 is equal to 0, right? Now this is the Cartesian equation of this plane P, and we can convert this equation into vector equation. So we can write vector r dot 33 I cap plus 45 j cap plus 50 k cap equal to 41. So this is the required vector equation of this plane P, and from here we also conclude that the dr's of this normal vector, dr's of the normal vector to this plane P are given by 33, 45 and 50, right?